All right, let's talk about section 1.6. This is one of my favorites. We're getting into the things that I really, really like about algebra. And that's the idea of moving and talking about functions as rules and tables, which means we're really getting into talking about them as rules, tables, and graphs. But graphs won't come till section 1.7. So let's talk about vocabulary because that's a great place to start, everyone. We're going to start this section talking about domain and range. Remember, and I know you've seen this before, domain goes with input. Domain are input values. And remember, those are usually x values or the numbers that we insert or plug into a particular situation or equation. The second vocabulary word, range, is talking about the output values. Range and output, or y values. Those three pieces are interchangeable. So what's my output? What's my range? What's my input? Now I want to throw a caution out to you with these two words because in this section we're going to talk about domain and range as being very finite, meaning that they're going to have exactly a certain number of values. And later in the year when we talk about domain and range, not too far down the road here, we're going to use those words and they're not going to be finite, they're going to be inequalities, or they're going to include more than just a few numbers. So I want to caution you that for this chapter, domain and range are going to be limited. And in the future, they're going to become unlimited. I promise we'll talk about it more, but I don't want you to think that I've tricked you or not told you everything you need to know about domain and range the first time I've introduced them. So we're going to take the first part to understand what we're looking at, and the second part, we'll start looking at the whole piece. The third vocabulary word here is the word function, a rule that establishes a relationship between two quantities called the input and the output. So a function is a relationship. The output is something that happened to the input. The nice part is this phrase right here. And actually I'm going to use a highlighter because it's a pretty important phrase. And it's the most important one. For each input, there is exactly one output. I'll read it again. For each input, there is exactly one output. So when I put in a number, I can't get two possible values. Because if I get two possible values, then I no longer have a function. I only have a relationship or a relation. To be a function, that relationship has to be one-to-one. One input gives me one output. We're going to talk about independent variables and dependent variables. Independent is, again, another word for input. Dependent, where's that green marker? There it is. Dependent is an output, y values. Now, some input-output situations that we know. Gallons of gas. So we put in gas in our car, and the output is the final cost of the gas. Well, we could come up with all sorts of things. Gallons of gas gets tied to all sorts of different kinds of output. Weight of a package, amount you pay in postage. The number of hours you work determines the amount of dollars in your paycheck. The speed of your car determines the time it takes you to drive to grandma's. So all of these pieces are relationships, some input-output relationships. Look back at the definition of a function. Would each of these situations be functions? It's an interesting question, and there's a little bit of opinion involved in there. I'm going to leave that one for you to fill in with your opinion and what do you think. And we're going to talk about this one in class. Would these be functions? Make sure you have something prepared so that you can talk about it. Would each of these be functions? Which column would be your domain? Which column would be your range? Hopefully that was pretty obvious, right? Input column, is your domain. It's what we have control over. We can control how many gallons of gas. We can control how much we put in a package. To some extent, we can control how many hours we work, and we can definitely control the speed of our car. What we can't control then, the part that's out of ours, is the output, the result. Right? We chose to put 2 gallons of gas in our car. So it only cost us $8. Right? There's all sorts of ramifications, there are all sorts of things that can happen, but we only put in 2 gallons and it only cost us $8 was the first output. And go through all of those in that manner. Now, that concept of being a function is very logical. In mathematics, we present it just a little bit differently. Tell whether each is a function and explain why. So we're going to look at our mapping first. That's what this little guy is called, a mapping. Because we have 2 bubbles and arrows, they like to call that a mapping. When we look at our mapping, we're going to look at the left side as the inputs and the right side as the outputs. They're not always going to be labeled like this. So input implies output. When we look at each of those inputs, it has exactly one output. So that in part A, this is a function because no input values repeat. Or sometimes we say that same phrase, part A is a function because no x values repeat. Or we might even say there is no repetition in the input values. You might see all sorts of different ways to say that, but we just simply need to say that for every x, there is exactly one y. Either way, kind of like that one too. I think I'm going to write that one down as well. I'll put it in green so we know it goes together. For every input, there is exactly one output. I don't think output got written very nicely. The computer can't seem to keep up. There we go. For every input, there is exactly one output. So now if we look at part B, let me change colors so we know we're talking about a different problem here. This one is no longer a mapping. This is now a table. And this table, input to output, input to output. This input value of 2 has 2 different output values. That's a repetition. So part B is not a function because the x value or the input value of 2 repeats. The input value of 2 repeats. Okay, let's move to part C. And the input-output table shows temperatures over various increments of time. Identify the domain and range of the function and determine whether it is a function. So we have to do both parts, right? We have to identify domain, identify range, and determine whether it is a function. So in this problem, our domain, our inputs, we had an input value at noon. We had an input value at 1 p.m., an input at 4 p.m., and an input also at 6 p.m. Our range values are 24, 27, 30, and 33. The table in part C is this a function? 4 different x values. So there's no repetition. So yeah, it is a function because no repeating x values, no repeating inputs. Would you please take a moment now and pause, try part D, and see how you answered. Welcome back, and hopefully the first thing you noticed was this repeating value of 5. So when you wrote down your domain, check it out. Do you have 5, 5, 10, 15? If so, if you listed that 5 twice, you didn't list your domain properly. We never write a value more than once when we write down domain and range. The range has the values of 3, 4, 6, and 8. The table in part D is not a function because the input value of 5 repeats. Or you could also have said there are more elements in the domain than in the range. So when we look at that, if your domain is smaller than the range, then we have a repetition and it's not a function. Alright, I'm going to pause it and you need to start the next video before you go to the next example.